All right, welcome back to another JNCIE-SP video. We're going to be focusing on the high availability topic under infrastructure. So it's infrastructure, device infrastructure, um, and then it's uh, high availability. And this particular topic is aggregated Ethernet, including fault detection. So to prepare for this, we're just going to be going through one of this lab here, and we'll be kind of doing a custom implementation of it because we won't be able to include quite this many links in there, but I think it'll be good enough to kind of learn the basic ideas. And we'll be including load balancing, we'll be including um, link protection. I thought we might not be including link protection. We could always just go and do that extra and then shut down links and see what happens when they fail. But the first thing we'll have to do is just apply all this configuration. So I'll make sure to type it out. This is interesting that they're saying device count is 12 for router 1 because we've only got 2 links. And it's even more interesting that on router 2 they're saying device count is 5 because yeah, it just seems like the device counts are not don't really make a lot of sense, but we might need to do some quality control on this, submit some downloads. But for now, let's just get on going. And of course, we're going to be using custom interfaces. We'll be using GE000 and 001. I don't understand why they have 4 links when their topology only has 2 links. And it looks like there's absolutely no GE-XE interfaces at all in the topology. But in here, but down here you can see there are XE interfaces. So looks like it's not aligning with the topology. Let's see if the IP addresses line up. 120.168.100.2. Okay, so it looks like the GE interface lines up. Okay, so they've just got extra XE interfaces included for some reason. I'm not sure if that's a part of the lab or what they were thinking with that. Oh, it looks like they're going to have OSPF enabled on there. Let's read more about the lab. I did skip reading over the overview. Load balancing is required on the forwarding plane when there are multiple paths or interfaces available to the next hop router, and it is best if the incoming router is load balanced across all available paths for better link utilization. Aggregated Ethernet bundle is a typical application that uses load balancing to balance traffic flows across the member links of the bundle. Starting with Junos OS 13.3, aggregated Ethernet load balancing is enhanced to provide 2 solutions for resolving genuine traffic imbalance on aggregated Ethernet bundles on MICs or MPCs of MX series routers. Starting with Junos OS release 14.1, aggregated Ethernet load balancing is enhanced to provide 2 solutions for resolving genuine traffic imbalance on aggregated Ethernet bundles on PICs or FPCs of PTX series packet transport routers. The aggregated Ethernet load balancing solutions are adaptive. Adaptive load balancing is used in scenarios where flow-based hashing is not sufficient to achieve a uniform load distribution. This load balancing solution implements a real-time feedback and control mechanism to monitor and manage imbalances in network load. The adaptive load balancing solution corrects the traffic flow imbalance by modifying the selector entries and periodically scanning the link utilization on each member link of the AE bundle to detect any deviation. When a deviation is detected, an adjustment event is triggered and fewer flows are mapped to the affected member link. As a result, the offered bandwidth of that member link goes down. This causes a continuous feedback loop, which over a period of time ensures that the same amount of byte rate is offered to all the member links, thus providing efficient traffic distribution across each member link in the AE bundle. To configure adaptive load balancing, include the adaptive statement at the edit hierarchy AEX aggregated ether options load balance hierarchy level. Adaptive load balancing is not supported if the VLAN ID is configured on the aggregated Ethernet interface. This limitation affects the PTX series packet transport routers only. So we're not going to have those. I think I'm not going to continue to read this. It's just a lot of stuff that only applies to PTX, and these are going to be MX on the routers. So I think I'm just going to kind of do it just the way I kind of think it would need to be done. Unfortunately, they don't give a full topology. It looks like it's just an abbreviated topology. So I'm not sure what they wanted, but let's go ahead with it. So okay, so we'll do edit, and let's make these XE interfaces, but let's just have them be GE008 and 9. This is something I always kind of struggle to understand why they have. So they have 1, 2, yeah. So it almost looks like they're just bunching the whole thing up. So they have 1, 2, 1, 6, 8. But then what I don't understand is why don't they have this next part be 0, 2 if they're going to do 1, 2, 1, 6, 8. If they're going to bunch up, oh, I see, because they're having yeah, I don't understand kind of their reasoning for um, grouping together parts of the octet. So what I did when I came up with this is you've got 3 octets. Oh, I guess I might have just used an extended one and then gave it an extra octet. Now that I think of it, I can go back and review the video, but I don't think it's that important. All right. Yep, so lots of good stuff in this example that I'm going to need to know on the test. Vidal to sweet. Yeah, all of this is going to be on there for sure. Label switch paths, RSVP. It might just be LDP, but oh, oh, because I'm in edit mode. Oops, that's not right. All right, so that's a lot of configuration. Oops, and it looks like, aha. So this is the classic error that they have in their documentation. So this is obviously meant to be a PE interface. It's meant to be an interface facing the customer router where traffic enters and leaves the VPN. So because of that, it's added to the routing instance. The core links, which are meant to be these GE interfaces, are not a part of that. So since they're PE interfaces and they belong to this special routing instance, they're actually not a part of the core, the default routing instance. So we're trying to add them by including them here in this MPLS statement. So they don't need to be included there because they're going to be imported into, yes. So because of this import policy here, well, actually, it's going to be uh, it's going to be, shoot, I don't remember exactly, but I do know that we don't need to include these interfaces to the customer router here for MPLS, just as we don't include them in ISIS. And you can see we don't even have, yeah, and just as we wouldn't include them in RSVP. So very clearly, since they're not included in RSVP, they're not included in ISIS, they don't need to be included in MPLS as well. So that's a big error. I have downvoted that before in other parts of the configuration. But I'm not going to downvote it here just because I probably could. I actually think it is probably worth a downvote because it's just a kind of a really inconvenient error. So I think this is worth a downvote. These are CE interfaces and cannot be included in the MPLS protocol. These are CE interfaces and cannot be included in the configuration under the protocols hierarchy. If MPLS is meant to be configured on these interfaces, I do not think it is necessary. However, the configuration must be added in the routing instance where the interfaces reside. Oops. All right, so everything is good to go with that downvote. Yeah, I think it's definitely worth a downvote. Okay, so let's move on to router 2. So we're going to have to use custom interfaces here. Now we won't be able to use as many, so we've only got, I think, 5 to work with. All right, so we're going to have interfaces 2 through 9. So 987, we're going to have 7 interfaces to add to the port channel, but we want 2 port channels. It looks like 1 port channel has fewer links than the other. So since we have 7, we're going to have to add 3 to one and 4 to the other, or 2 to one and 5 to the other. But I'm going to go with 3 and 4. So we'll have the lower numbered interfaces belong to AE1 and it will, AE0, and it will get 3 links. And we'll have the higher numbered interfaces belong to AE1 and they will have 4 links included. So there is a way, I know anyone really familiar with Cisco is kind of yelling at the screen right now and being like, oh, well, why don't you use something like interface range? So you can certainly do that in Juniper, but it's kind of a little bit of a fickle command. It can be kind of wonky, but you would use this wildcard here, and then you do range, and then you would do set interfaces, and then you would do interface range, and then you'd have to define a range name. So it's going to be range my range, I believe is how it works. Or is it like this? I think it's like this. So we're starting with 2, and then we're going to, because there's going to be 3 links added to this, so it'll be 5. So we're going to add 2. Oh, actually, it's going to be through 4 because we're going to add 2, 3, and 4. It's counting 2. So, okay, so I think this is how it goes. Nope. Oops. There we go. And now we can add the gig ether options. 802.3AD, AE0. Oops. So must start with a letter followed by, okay. So let's try my range. Okay. So yeah, and see what I mean? It's kind of, it makes things more difficult, especially since you can just up arrow, and it's yeah, like what is that my range doing? So it's definitely something you can learn to do, but will it save you time and hassle? That's arguable. Of course, if you've got 40 links, yeah, you're gonna want to learn that, but right now we've only got 3. So there's the first link, second link, third link. Now we're going to need to add 4 links to AE0. First link, second link, third link, fourth link. So I was actually off by 1. We, instead of having 7 links, we actually do have 8 links. So I miscounted. I think I forgot to include one of the links. Like if I was counting 1, 2, 3, 4, 5, I would have counted the spaces between the numbers and not every individual number. So I was counting the fences, but not the fence posts. So in this case, we need to count the fence posts. So we're going to have 8 of them. So let's just let's have them be uneven like they are in the example. So we're just going to add an extra 1 to AE1. All right, now we need some more configuration on the AE interfaces themselves because we're going to set up some extra features. Kind of been violating my rule a little bit by using the tab key when I haven't used the command a million times. That's kind of a rule I like to have, is if I'm not absolutely sick of typing out the command, I'm learning it for the first time, I don't like to use that tab key because it's meant to be a tool to speed up your entering the commands. But if I'm learning the commands for the first time, I want to be slow and methodical and look at all the help menu and kind of take it in instead of just rushing through everything. Okay, so there's the extra features. So now we're going to need to set up the regular parameters you would set up for an interface that is not a port channel. So these are regardless of whether the interface is a port channel or not. So of course it needs basic things like a IP address, And then in this case, we're using ISIS for the IGP, and we have MPLS LSPs as well, label switch paths. I forget what MPLS stands for again. Multi-protocol label switching, I think it stands for. That's the other thing. I like to know what the acronyms mean. Because usually the acronyms, if you expand them out, it's a clue as to what it actually does. And then you, of course, don't get that sort of clue just by the acronym itself. And as I've said many times before, one of the main running themes in this channel is concepts, not commands. Oops. There we go. Just doing up. So I think oh, no, we're going to be fine. Because this is not a entry point to or from the L3 VPN. So we're going to need to add all of these interfaces to protocols such as RSVP, MPLS, ISIS. It's not going to be dependent on whether or not they're a part of the L3 VPN, because they're just going to be transparent transports for L3PN traffic. They're not going to participate in the L3PN itself. That's just going to be at the entrance and exit points. And then the traffic gets marked with all the L3PN attributes and passed silently through the night on these transit routers. But they do need to have RSVP, MPLS, that sort of thing set up, because it's going to be moved through these routers as a label and not as a route. Perfect. Everything is good to go on router 2. Let's see if this configuration commits. And it does. On to router 3. Oops. And of course, these are going to have special. So this is kind of interesting because it has. This is of course an exit point and an entry point to the L3 VPN. So it's going to have extra links allocated to that L3 VPN. So in our case, because we've only got 10 links, we're going to need to use fewer links in our 802.3AD aggregated Ethernet interface. So on router 2, we're going to have to take away 2 of those links because we're going to fill up router 3 all the way in order to have links to the CE device. So, I mean, we could certainly do that. It's kind of, I think, a little bit unideal because we get fewer links in those port channels. But I think it's not going to make a huge difference. And then I definitely want some more practice on L3 VPNs. And I really haven't shown them that much on this channel too, because for an L3 VPN, I had completed the whole topic before I had decided to make YouTube videos of my study. The reason I just decided to make YouTube videos, I actually didn't decide to do it until, as I said, I completed the whole topic on this exam. But I just wanted a record and proof and evidence that I actually did put forth a lot of effort to study and prepare for this exam. That way, even if I fail it, I have something to show for it. And not only that, I can go back and say, oh, well, I spent way too much time reading RFCs. Oh, well, this wasn't on the exam and I didn't even get to it. Or, oh, this was it said I got really low marks on this topic. Well, let me go back and see what I did to study for that topic. Oh, sure enough, I gave the topic not enough time. I kind of glossed over things when I did the video. So I think this is a really good idea. Unfortunately, the YouTube platform kind of leaves a bit to be desired for this. I don't get the running amount of time that I uploaded, so it's kind of hard to keep track of my individual metrics for how long I studied. This is interesting. So it looks like the option to have a port channel on this side is missing. Yep, so this is certainly how you would make a port channel. I wonder why it's missing from this side. Oh, yeah, it's completely missing. Oh, no, it's not. There we go. Okay. So we're going to add 3 links to that. Link 2, 3, and 4. Oh, okay. We actually will be able to add all of the links. We don't have extra links on router 3. We've got 2 links going to the CE router, but on router 2, we also had 2 links that were utilized going to router 1. So we've got the same number of links utilized on router 3 and router 2. So that's not going to be a problem, thankfully. So now we can add 5, 6, 7, 8, and 9 to AE1. But of course, links 0 and 1, those we're going to have to leave empty on here. And I believe, yep, okay, they are empty. Yep, 2 and 3 are empty, which map to 0 and 1. So let's continue on with the configuration. Not sure what VDEL is. Is that a country or something? I'm kind of curious to look that up. It's kind of a word I've never seen before. Oops, there we go. Oops. So this is now the import statement. It's for taking routes from a routing protocol and putting them into a routing table. The export is to take them from the routing table and put them into a routing protocol. So it looks like they're just doing the same import configuration as they're doing for the export configuration. I don't think that would be necessary. I think they just go into the table by default. So you would only need to do a import statement if you wanted to weed out certain routes and not have them go into the routing table, or if you wanted to get around the normal rules of what makes it into the routing table and have a custom route go in there. You can increase the metric or do something like that. So I'm really not sure what they're getting at with having import configuration that matches export configuration. It's, I think, just kind of makes it harder to learn the subject matter if they're not using it in the way that it is intended to be used. So you can see it's a CE port, customer edge, group CE. So clearly that customer device has BGP running on it. All right, so everything looks good. Let's skim over the step-by-step. I don't see anything standing out. All right, so the next step is going to be the validation, but this video is coming on 1 hour, so I think I'm going to save that for the next video. Oops, and we've got the same error that was there before. So we can just go into edit protocols in PLS, show pipe display set relative, and sure enough, if I do a commit check again, those links to the CE, they're not going to belong in MPLS, at least not in this default instance. But I think it will be plain to see if they have to be added to the routing instance. All right, so hopefully that commits now. Oops, and interface is not in this instance. Oh, right, so they do. Oh, okay, it looks like they were added to RSVP as well. Yep, so they don't need to be in there either. Oops. All right, so we're good to go. Thanks for watching this video. Stay tuned for the next one where we verify this configuration. Have a good night.